Imagine being able to ask your database questions in plain English and instantly get the answers you need, no SQL expertise required. That's the promise of text-to-SQL systems. In this video, we'll explore how modern AI tools like Retrieval-Augmented Generation, RAG, LangChain, FastAPI, and Streamlit come together to make this possible. Whether you're a business user, analyst, or developer, this technology bridges the gap between natural language and structured data, making insights accessible to everyone. Let's dive into the journey from a simple question to a powerful, actionable answer. SQL is the backbone of data analytics, but its syntax can be intimidating for many. Business users often find themselves waiting for technical experts to write queries, slowing down decision-making. Text-to-SQL changes this dynamic by allowing anyone to ask questions like, "What were our top 5 selling products last quarter?" and get answers directly from the database. This democratizes data access, unlocking insights that were previously trapped behind technical barriers. In today's fast-paced world, making data askable is a game-changer for teams and organizations. Large language models like GPT can generate SQL queries from natural language, but there's a catch. They often hallucinate table or column names, or miss relationships in your actual database. For example, you might ask for customers who joined last month, and the model invents a table that doesn't exist. This is because LLMs don't inherently know your database schema. Without grounding in real schema context, their answers can be unreliable or even wrong. That's where Retrieval-Augmented Generation, or RAG, comes in. Retrieval-Augmented Generation, or RAG, is a hybrid AI approach that combines 2 steps: retrieval and generation. First, the system fetches relevant schema information like table names and relationships from your database. Then, it uses a language model to generate SQL queries based on both your question and the retrieved context. Think of RAG as giving your AI a cheat sheet, ensuring it always works with up-to-date, accurate schema details. This dramatically reduces hallucinations and grounds every query in reality. Let's break down the RAG loop. When a user asks a question, the system first retrieves relevant schema info from a vector database. Next, the language model generates a SQL query using this context. The query is then validated and executed against the real database. Finally, the results are returned to the user. This loop ensures that every SQL statement is grounded in the actual structure of your data, making the process reliable and robust. Now, let's look at the big picture. Our Text-to-SQL chatbot is built from several key components. A SQLite database is the data source, an embedding layer to turn schema into vectors, a Chroma vector store for fast retrieval, LangChain components to orchestrate the workflow, a FastAPI backend to serve the pipeline, and a Streamlit UI for user interaction. Each layer plays a crucial role in transforming a simple question into a precise SQL query and readable results. Before the AI can generate accurate SQL, it needs to understand your database's structure. This is done by converting table names, column names, and even sample data into numerical vectors using Hugging Face embeddings. These vectors capture the semantic meaning of each schema element, allowing the system to later retrieve the most relevant context for any question. This embedding process is the foundation for smart, context-aware SQL generation. Once the schema is embedded, these vectors are stored in a Chroma vector database. When a user asks a question, the system embeds the question in the same vector space and searches Chroma for the closest schema elements. This ensures that only the most relevant tables and columns are used to generate the SQL query, grounding the model's output in reality and reducing errors. LangChain ties all the components together. It provides modular tools for retrieval, reasoning, and SQL generation. Retrievers pull relevant schema from Chroma. Chains define the sequence of steps. And language models generate SQL queries based on both the user's question and the retrieved context. LangChain ensures that every question goes through the full RAG loop, making the system robust and extensible. To make the system interactive, everything is wrapped inside a FastAPI backend. FastAPI exposes the RAG pipeline as an API endpoint, handling requests from the frontend. When a user submits a question, FastAPI retrieves schema info, generates and validates SQL, executes the query, and returns the results. This layer is fast, scalable, and easy to deploy, making it ideal for production environments. On the front end, Streamlit provides a simple, interactive web interface. Users can type natural language questions, choose to view the generated SQL, and see results in real time. Streamlit's ease of use makes it perfect for prototyping and deploying AI-powered dashboards, allowing anyone to interact with data conversationally. Let's walk through the full query flow. The user enters a question in Streamlit, which sends a request to the FastAPI backend. The backend retrieves relevant schema from Chroma, generates SQL with the language model, validates the query, and executes it on SQLite. The results are returned to Streamlit, where they're displayed instantly. This seamless pipeline turns plain English into actionable data insights in seconds. In real-world scenarios, databases or dynamic tables change, new records are added, and schemas evolve. To keep the RAG system accurate, embeddings must be updated incrementally. By tracking changes and re-embedding only what's new, you ensure the system always has the latest context without unnecessary overhead. Background jobs or async tasks can handle these updates efficiently, keeping the user experience smooth and responsive. There's plenty of room to innovate further. You can fine-tune the SQL generator on your company's query logs, add caching for frequent questions, or integrate dynamic charts into Streamlit for richer data visualization. For larger datasets, consider switching to scalable vector databases like Pinecone or Qdrant. Feedback loops can also help the system learn from user corrections, making it smarter over time. By combining RAG, embeddings, and conversational interfaces, you've built a system that democratizes access to data. Anyone can now ask complex questions and get instant answers without writing a single line of SQL. This modular, scalable architecture is production-ready and adaptable to evolving business needs. As AI continues to advance, tools like this will make data-driven decision-making faster, easier, and more inclusive than ever before.